Hello. So in yesterday's video, we looked at the partial fraction decomposition number one, the first partial fraction decomposition, and this is this decomposition here. So we did this in the previous video. So when you've got a fraction like this here with a product of linear factors on the bottom here, you can actually decompose it into two different fractions like this, where a and b are constants. So these capital A and capital B values just numbers that you need to find out. But you can actually break it into two separate fractions with these linear factors as your denominators there. So that's what we did in the previous video. In today's one, we're going to look at partial fraction decomposition number two. I'm going to call this our second one. So this is when, again, you've got a linear, like a linear factor on your numerator, or it could just be a constant as well. A could be zero as well. A can be any number that you like, over the product of the square of a linear factor. Let's say you've got a linear factor cx plus d, and you're going to square it. How would you break this into partial fractions? And this is the formula that you would use here. So it's going to be a number that you need to find out, a capital A, over the factor, plus another number that you need to find out, divided by the factor squared. So that is actually the rule that you need to learn here. So to break this, something that looks like this, into partial fractions, you have to use this formula here, where A and B are capital A and capital B are constants in which you need to determine. We'll go through an example in a minute. But actually, you can combine the combination number one and combination number two. So these decompositions number one and two, you can actually combine them into like one bigger rule like this. So let's say you've got like a quadratic factor on the top. Again, A could be zero, B could be zero. As long as C is just a non-zero number, then that's all fine. So this can be any expression up to a quadratic. Divide this by a linear factor times by the square of a linear factor. If you want to break this into partial fractions, you'll actually get three fractions. So you get a number divided by the linear factor dx plus e. You get a number again divided by the linear term fx plus g, and then you get another fraction, another constant. This should be a capital C. Let me just emphasize this is a capital C, divided by this linear factor again squared. So the one that we square. So that's kind of how you do a combination of decomposition number one and decomposition number two. Let's look at like an example then. So the question is to write x plus 4 divided by 2x plus 1 times by 4 minus x all squared into partial fractions. So we're going to use our formula, this formula here. So we've got a capital number that we don't know, another number there we don't know, another number there we don't know. So using our formula, our first denominator is going to be this 2x plus 1 there. Our second denominator will be 4 minus x, so this factor there. And then the next denominator will be the square of that one, so the factor that we're actually squaring there. So that's going to be that. Now it's a case of just finding out what A, B, and C are. That's what we need to work out. So how could we do this? Let me just move my writing up to that. So again, we're going to multiply both sides. So multiply both sides by this denominator on the bottom, so like we did before in the previous video. So multiply both sides by 2x plus 1 times by 4 minus x all squared. And if we do that, we will get x plus 4 is equal to, so this fraction times by this denominator. So what will happen is we're going to get a times by 4 minus x all squared, because the 2x plus 1 will actually cancel out with this 2x plus 1 there. So that's why we don't need that there. We're just going to have a 4 minus x all squared factor next to it. Then we're going to add this fraction multiplied by the denominator. And again, what will happen is that the 4 minus x factor will cancel out. So we've got b times 2x plus 1 times by 4 minus x there. And then finally, our last term, again, let me just try and squeeze this all up. So our last term, we will get plus c, and then times by this fraction times by our denominator there. The 4 minus x all squared will cancel out, so we just get c times 2x plus 1 there. Okay, so now it's just a case of expanding our right hand side. So you've got a times by expanding these brackets here, we'll get 16 minus 8x plus an x squared, and then plus b lots of expanding these brackets, we will get a minus 2x squared, a 8x take away an x, so that'll be a plus 7x, and then finally a plus 4 there. And then our last part, so c times that there, it's just c times 2x plus 1. So again, if we just simplify what we've got then, so we've got a times x squared there and b times negative 2x squared there. So really what we've got is we've got a take away 2b times x squared from those two terms there. Okay, so next we've got a times minus 8x, so minus 8ax, and then plus a 7bx there, and then plus a 2c x there. So really what we've got then is you've got a plus minus 8a plus 7b plus 2c lots of x. And then lastly, we've got 16a there, we've got 4b there, and we've got 1c there. So plus our constant term of 16a plus 4b plus c at the end there. Okay, great. So now then we can compare our coefficients. So again, on our left-hand side, we've got 1 loss of x, 4 as a constant, and we've got, let's just make a note of this here, we've actually got 0 x squared there, haven't we? So 0 lots of x squared. So we're going to get 3 simultaneous equations. So 0 lots of x squared on our left side equals a minus 2b lots of x squared there, because again we've got to match the coefficients. So the coefficient of x squared on the left side is 0 because we've got no x squareds there, but on our right side it's a take away 2b, so a take away 2b must be equal to 0, so that's going to be equation number 1. Equation number 2, so our coefficient of x there is the number 1 on the left side, our coefficient of x here on the right side is this minus 8a plus 7b plus 2c, so we get minus 8a plus 7b plus 2c is equal to the number 1. And then lastly, this number 4 must be equal to this constant term at the end there. So the number 4 is equal to 16a plus 4b plus c. And then it's just a case of solving these 3 equations simultaneously then. So, I mean, if we just look at our first equation number 1, sorry, let me just try and keep everything on the same page. So our first equation number 1, we can say from this that a is going to be equal to 2b. So we know that a is equal to 2b. So let's just substitute this into our second one then. So we've got minus 8 times 2b plus 7b plus 2c equals the number 1. Okay, so this is going to give us minus 16b plus 7b plus 2c equals 1. And minus 16 plus 7, well, that's going to give us a negative 9b. So negative 9b plus 2c is equal to 1. So what we can say, therefore, is that c, just by making c the subject of the formula, is going to be 1 plus 9b divided by 2. Okay, so we know that for a fact. We can now plug this into our third equation. So we've got the number 4 is equal to 16a, so 16 times by 2b, because a is 2b, so 16 times by 2b, plus 4b, and then plus the c, which is 1 plus 9b over 2. So this is 32b, so 32b plus 4b plus a half plus 9 over 2b. So in terms of all the b's that we've got here, so we've got 32b plus 4b, 36b, then we got a 4.5b there because 9 divided by 2 is 4.5. So what we've got really is so 40.5b, which is the same as 91 over 2. So we've got 91, sorry, my bad, 81 over 2, sorry. So we've got 81 over 2b plus a half is equal to 4. So rearranging this for b then, so this is going to give us, so 4 take away a half will be 3.5. I'm actually just going to keep it in decimals just because it's easier for my head to deal with. So 3.5 is equal to 40.5b. So that means then, again, I'm just going to try and keep my writing all on the same page. So that means that it must be true that b is equal to 3.5 over 40.5. I'm going to put this into my calculator. So as a fraction then, b is going to be 7 over 81. So we get 7 over 81 for b, because again, when we add those numbers together, we will get 81 over 2b plus a half. And then when we subtract the half, divide by the 81 over 2, we do get 7 over 81 for b. So now we know that a is going to be double the value of b. So a will actually be 14 over 81, just because a equals 2 times b. And then c, we know, is 1 plus 9b over 2. So 1 plus 9 lots of 7, that would be 63 over 81. And then divide that all by 2. Again, I'm just going to put this in the calculator. So yeah, so 1 plus 63 over 81. Divide that all by 2. So as a fraction, we get 8 over 9 for c. So this equals, we'll just fit this in here, 8 over 9. Okay, so now then we've got our a value, we've got our b value, we've got our c value. So now we know our partial fraction decomposition, what that would actually turn out to be. Let me just try and move this across. So it means that x plus 4 over 2x plus 1 times by 4 minus x all squared is exactly the same as the a over 2x plus 1. So 14 over 81 times by 2x plus 1. In addition, with b, which in this case is 7 over 81, so 7 over 81, divide that by the 4 minus x, and then plus finally the c value. So 8 over 9 divided by 4 minus x all squared. So that would be our partial fraction decomposition for this specific fraction here. So again, it's the same kind of process as before. We're just combining this decomposition number 2, so this fact here that you need to learn, this one here, with this fact here that you need to learn. So you can combine these two combinations, these two decompositions, and you can answer questions like this. Essentially, that's kind of the idea for today's video.